After some 20 years of development, 6 years of construction and more than a year of testing, Solar Orbiter is being readied for launch from Cape Canaveral, Florida on an Atlas V. Built by Airbus in the UK, engineers have had the challenging task of designing a mission to make detailed observations of the Sun, capture the closest ever pictures of our nearest star, and the first images of the poles.
The spacecraft has a number of key new technologies that have been developed just for the purpose of flying close to the Sun. We have a specific heat shield designed just for Solar Orbiter that will reach temperatures of over 500 degrees centigrade on the front side and will keep things as cool as just about 50 degrees centigrade on the backside to protect the sensitive electronics.
The Sun generates a bubble of plasma enveloping the entire solar system. Known as the heliosphere, anything within it, including Earth, is subject to a stream of charged particles called the solar wind. Violent space weather from flares and coronal mass ejections has the potential to damage satellites, disrupt communications and knock out power grids on the ground. Solar Orbiter will help answer fundamental questions about the Sun's activity.
One of the key questions the scientists have is how the heliosphere is actually generated and how it's accelerated. So what is really driving the solar wind? And the second key question of the mission is understanding what makes the Sun change or vary over this 11-year cycle that we all know. So understanding the magnetic properties of the Sun and how these change over this 11-year cycle is one of the key scientific objectives of Solar Orbiter.
To measure the magnetic environment around the Sun, Solar Orbiter is fitted with a suite of 10 extremely sensitive instruments. And so it can take pictures, the heat shield has peepholes through it, covered by protective doors.
We're going to places where no other solar telescopes have been before. We're going to be very close to the Sun to take very high resolution images of the Sun, unprecedented spatial resolution, and we are also going to fly over the poles of the Sun, regions that are very much unknown because we don't see them very well from Earth, but they are the source of the fast solar wind and therefore are very important.
Solar Orbiter will take several years, using the gravity of Venus and Earth to reach its operational orbit. But once in position, the spacecraft will take measurements that complement NASA's Parker Solar Probe, which launched in 2018.
We will not get as close to the Sun, but we will have a vastly bigger payload complement, so more instruments with more cameras looking at the Sun. So we will do science that is complementary to Solar Probe, and the two will really have a great deal of synergy.
With launch preparations underway, the engineers and scientists working on Solar Orbiter can now look forward to their hard work revealing our Sun as never before.